First, we have the magnet. Its job is to provide the magnetic field. This creates the force needed to make our coil spin. 9-volt battery with a connector snap or loose wires. This is our power source. It supplies the electric current and voltage needed to make electricity flow through the wire. 2 paper clips. We use this to make the stand or support. They hold our coil in place and allow it to turn freely without touching any surface. Sandpaper. It is used to scrape off the coating or insulation from the copper wire so the metal part is exposed and electricity can flow properly. A piece of cardboard. It will act as our base that will keep all parts stable, hold everything in place, and make it easier to handle and arrange the motor. Next, we have a copper wire. We shape this into a coil. Leave about 3 centimeters of straight wire on both sides. This coil becomes the rotating part of the motor. And lastly, we have electrical tape. We use this to secure all parts firmly together.
First, we need to make a support. Strengthen 2 paper clips, leaving a loop at the top, then tape them vertically to the board. Next, we need to make a wind coil by wrapping copper wire 10 to 15 times around a round object. Leave 1.5 inches of straight wire sticking out on opposite sides. Using your paper sand, scrape insulation completely off one wire end. Scrape only at the top half of the other wire end. Balance the wire coils once you hang it into 2 paper clips. Connect the red or positive wire of your battery to one paper clip and the black or negative wire to the other paper clip using tape or clips.
Few moments later.
A simple motor works by using electricity to create a magnetic force that produces motion. When current from the battery flows through the copper coil, it transforms the coil into a temporary electromagnet. The magnetic field of this coil then interacts with the field of the permanent magnet on the base. The resulting repulsion and attraction provide the physical push that makes the coil spin. To ensure the coil keeps spinning in one direction, the insulation is stripped off only one side of the wire ends. This acts as a switch that turns the current off for half of every rotation, preventing the magnetic field from pulling the coil backward. Momentum carries the coil through this off pace until the bare wire touches the support again, providing a fresh pulse of energy to maintain continuous rotation. The fundamental principle behind it is Lorentz force. When an electric current flows through a wire that is placed within a magnetic field, the wire experiences a physical force. The direction of this force is determined by Fleming's left-hand rule. Thumb represents the direction of the force or the motion. Index finger, direction of the magnetic field, north to south. And the middle finger, direction of the current, positive to negative.